Hi guys, so we're going to do graphing and solving inequalities. So we're going to use what we learned with equations to solve, and we're going to learn some new stuff on the graphing. So first things first, we have our different symbols. So when we have our little Pac-Man symbol pointing to the left, you have your less thans. So you have less than, and then you have a less than, or equal to. And then when you have the little, alligator symbol pointing to the right, those are your greater than. So without the line is just a greater than. And then with the line, you've got your greater than or equal to. So for this first one, x is less than 0. We're going to put an open dot on 0 because whenever you have a less than or just a greater than, it's an open dot. And then when we talk about interval notation, we're going to use, the open parentheses like that. So make sure you add those in there. So we're looking at where to shade. Now we have our open dot. Our open dot means that we're not including. Okay, so we're not including 0, but we want to know the range of all the values that are less than 0. So less than 0 would be all these negative numbers. And then with an arrow, you're going to point it to the left. So then same thing, we have a greater than, it's an open dot, and we want to know all the numbers bigger than 0. So all the numbers bigger than 0 are to the right, so with an arrow, you're going to move it to the right. So now that we have our less than or equal to and greater than or equal to, we're going to use a closed dot to show the equal to, because we're including it. So this is including. And then the other thing we're going to add in there is these brackets. So when we do interval notation, you'll have the brackets. So on 0, we're going to have a closed dot, and then same thing, less than or equal to goes to the left. Greater than or equal to, we're going to shade to the right. And we have to have arrows because it goes on forever and ever and ever. So first things first, let's talk about number 1, all real numbers, x less than or equal to -7. So x less than or equal to -7. So when I graph on my number line, I should have a -7, and then to the left I'll have the smaller number, which is -8, and then the -6 is greater, so we're going to have that to the right. It's going to be a closed dot, and we're looking for numbers less than the -7, so we're going to shade to the left and put an arrow, okay, because you want all those numbers. So then we're going to take a look at number 2, because there is a little separation right here. So number 2, 6 less than a number is greater than 13. So is greater than 13. Okay, that's where our inequality goes. And then 6 less than a number k, so 6 minus k, or 6 minus k minus 6. Add your 6 over. So then we have k greater than 19. So 19, 20, and then we have an 18 over here. It's an open dot because we're not including, and then we're shading to the right because it's greater than. Okay? So what I want you to do, I want you to try these next 4 on your own, because I think for the most part this is review for you. So go ahead and do those now. All right, so these are the answers you should have for 3, 4, 5, and 6. The big thing we need to talk about for 5 and 6 are these keywords here. So hopefully when you tried them, hopefully you were able to figure those out. So for 3 and 4, check those. Those are pretty straightforward. 5 is at least. So you need to ask yourself, is at least. So you could, if your mom says you could at least clean your room, can you do more chores than just cleaning your room? So could you also do the dishes? Could you also go mow the lawn? So when you say at least, you're saying at a bare minimum, X has to be this number, but it could be more. Okay, so that's why it's a greater than. For 6 is at most, let's say I have at most $20 in my pocket. So could I have more than 20 or could I have less than 20? Well, you can't have more because you're saying at most. That's the most I could have. So could you have less than 20? Yeah, so I could have 10, but you know, if I'm guessing, maybe I have at most $20. So for here, for 6, at most means less than or equal to. Okay. So moving along, we just have a bunch of practice problems. So for 7 is the number of solution of that inequality. So for A and B, you there's a couple of things you could do. You know, you have these two numbers. How would you determine if they are a solution to that inequality? Well, you could plug it in, okay? Or you could solve your inequality and go from there. So if I wanted to solve, subtract 1 over, so I have 2x is greater than -4, divide by 2, x is greater than -2. So if x has to be greater than -2, is -3 an answer? Okay, it wouldn't be because -3 is less. Is -1 an answer? Is that bigger than -2? And it is. Okay, so when you're negatives, the closer you get to 0, the better. So I want you to go ahead and do number 8 on your own. Go ahead and do that now. All right, so what you should get for 8 is that B and D both work for this particular inequality, because it can be 1 because of the equal to, but it's also greater than 1. So for this part, I want to make sure that we're practicing our graphing. So we're going to do 12 together. So the inequality I want to graph is 2x plus 1 is greater than or equal to 5. So solving equations, well, it says write an inequality from the graph. So we're going to do it this way, and then I'll give you one that we're just going to do it from the graph. So I want to practice solving, so I'm going to subtract 1 over. So you have 2x is greater than 4, divide, and then you have x is greater than or equal to 2. So close dot, greater than, you're moving to the right. So I'll actually follow my own directions now and go from the graph. So I want to, for number 13, I want to create an inequality based off this picture. Okay, so I know it's an open dot, so I know it's a less than or a greater than. My equal to's are gone. And it's to the right where all of my big numbers are. So if I keep my variable on the left, I prefer to have my variable on the left because then for those of you who like the little trick of where it's pointing, it actually works. So what I mean is if you say, okay, well the arrow's pointing to the right, which means it's a greater than. If your variable's on the left, it works. If your variable is on the right, it does not work, okay? Because you would just look at this point and say, well, it's pointing to the left, so the arrow has to go to the left. That's not true, okay? So make sure that if you're one of those who likes the hint, I don't like the hint. I think it's pretty terrible. If you're a hint user, which you can be, that's totally fine. Make sure that your variable is on the left. So variable on the left, x is greater than -2. Okay, so for 14 and 15, I'm going to create a graph, and then I want you to do those on your own. So I want to do, I have this graph, and then I'm going to have you try this one. Okay, I want to see how you do with 15. So go ahead and do those now. All right, so for 14, you should have x is less than 2, or less than or equal to, I'm sorry, less than or equal to 2. And then for 15 was a little challenging. I put open dots on -5 and 0. So really if you were thinking about how to graph this, you know that this left side goes to the right and it goes on forever and ever and ever. And if you remember from last year, you also have this from 0 going on forever and ever and ever. And then where they overlap is their solution set, which is what we have here. So you have two inequalities that you can turn into one, and we're going to talk about this. This is why I wanted to introduce it. So if you wrote x is greater than -5, you are correct, but you also have to include x is less than 0, okay? And when you combine the two, you get this long inequality right here, which is the one correct answer. So for right now, I would accept this if that's what you said. But this is how you would put it together. Okay, so hopefully that wasn't too bad. Um, so we're gonna go ahead and skip these guys. If you have any questions, please let me know. Have a great day.